Well, good morning, everyone. It's Monday. This is Memorial Day, and as seems to be the typical thing in the Black Hills on Memorial Day, it's raining. So we are still out in the field. We're starting week 3 of our field camp. And so the first week we did stratigraphy and then produced engineering stratigraphic columns, so looking at engineering properties of the rocks. Last week we had the students make their first geologic map, and there was also an engineering project involved with that. They didn't talk about that in the videos last week, but they had several things they had to do from an engineering perspective. And then for these next, the last 3 weeks of camp, it's really an engineering camp. And so today we are out on a one-day project. It's an individual project, and it is developing a Bedrock-Soils map, so basically a contact map of soil and bedrock for the purpose of developing home sites on about a 200-acre area in the Black Hills, that each of the sites will have an on-site wastewater system or a septic tank. And so there's laws and criteria that South Dakota has on depth of soil above bedrock and or groundwater to be able to install an on-site waste system. And so the first step in that process is mapping where the bedrock soil contacts are, and then making some inference on whether that contact has the criteria for depth on the soil, or you have to move away from that contact some feet out into a valley or something. And they're going to be making those types of decisions with mapping symbols on where the contacts are, and then where the minimum depth requirements are, which is for the state of South Dakota, below your septic tank there has to be a minimum of 4 feet of soil above either bedrock or groundwater. So you're going to need at least 8 to 10 feet of soil depth to be able to install a septic system. So that's what they're doing. The forecast, it's already rained quite a bit since last night at 5 o'clock until this morning. I've had 0.6 inches of rain at my house. It doesn't look like it's rained that much here. The ground is wet, it's muddy. We are slipping and sliding in the vans coming in, but we got to a point and parked. You can see the vans parked down there. So this dirt road coming in was pretty sloppy, but we got in, and it's nice now. It's overcast. It is not raining. I put my rain gear on though, just to keep my feet and my pants dry. And the next big forecast for rain is about noon, and so we're still supposed to get about 1 inch today, and some of the models say between 1 and 3 inches, so it could get after it this afternoon. So we're just going to see what the morning brings and go from there. Okay, so one day projects mostly for the first few days this week, and then there'll be a team project toward the end of the week. So for right now, I'm just wandering up this hill to see what's up top up here, and I'll be just shooting a little bit of video through the day, and we'll see how it goes. So thanks for watching. Sit back, grab a cup of coffee, stay warm, and see what we do out in the field. So you can see this is a valley down here. So there's soil down there, there's rock over there. So there'll be a bedrock soil contact right along the base of that little hill. And then of course I'm coming up on a hill here, which typically means that there's bedrock somewhere that is providing the competency for the hill to exist. And so they just walk along and try to find outcrops, and then from mapping locations of those outcrops they'll be able to determine with pretty good level of certainty where the bedrock is, where the soil is. The problem is, this is soil, right? But how thick is it? So that's part of the map. That's why it's preliminary. And then if this was a real project, the first thing to be done is whoever was developing this would bring out a backhoe and they'd start making some test pits, trying to check depth of soil. There's forestry going on out here right now. They're cleaning up stuff. So chips all over, some limb piles in here. So yeah, it looks really good when they've cleaned this out and thinned it out. It's been really raggedy in here the last couple of years. There's bedrock on that hill right there. So I'm up on top of one of the little knobs here, and this has a terrace gravels on it, so it's a gravel cap. And the issue with this project is we don't know how thick this is. If it was 20-30 feet thick, this would be a very nice home spot up high. You can see. So a good view up here. You know, there's already some homes down that valley. Looking across the valley, there's a huge cliff over there of Precambrian quartzite. This is a nice, like I say, a nice cap up here that's all terrace gravels. So that ridge over there on the horizon, that's on our mapping area, goes right over the other side of that ridge. Yeah, they're out working today. I don't know if you can see somewhere down here, there's a red tracked machine that's got a grinder on it, and they're going over all their cut limbs and whatnot and just mulching it up. So we're not the only ones out here today. Let's head over this way. You see another, like a plateau over there. Let's go check that out. Okay, across that little valley and got into a pile of quartz boulders in here. So it's probably a quartz ledge in here. No big deal, but back in the day, 130, 40 years ago, this is what the prospectors were looking for, is the quartz boulders. And then they would excavate little test pits around here to try to find gold. So this is quite a vein through here of quartz boulders. I don't see any sign of a pit yet, but I can almost guarantee you we will. So this whole hillside here, so this is a quartz vein under us, and these are just the, you know, the superficial weathered boulders of the quartz that are kind of breaking off of the vein. Well, and that's it. Looks like just the slope of that hill up to right here in front of us. Oh, and here is a test pit. I told you we'd find one. There's always test pits. So top of the ridge. So this is 12 feet across. It's probably 5 or 6 feet deep, but who knows how deep it was, you know, 100 some years ago. It's probably filled in now. And that's what the prospectors did. Dig holes, wear their bodies out, and very few of them made any money. Yeah, it looks like a couple of trail cams up here. I sure hope the Forest Service didn't sell this off to private. Seems like they do that a lot. This is just really beautiful. Be a shame to see it go to private. Oh, nope, not trail cams. Some kind of bug catchers. Maybe they're doing something with pine beetle study or something. Huh. Don't know what those are. There's two of them sitting here though. $127. Well, I don't see any kind of entrance hole. Interesting. Don't know what those are. So this is phyllite or schist. So metasediment started life as a shale or a mudstone, and then is metamorphosed into this foliated, crystalline, micaceous, sandy rock that texturally this stuff would be a phyllite, but we get lazy around here. Most people just say, you know, schist. They just refer to it as a schist, and it probably is not a schist. It's not coarse enough grained. This is pretty fine grained material. But it's resistant, and so you can see it's forming the ridge caps here. Let's go peek down into the valley on the other side here. This is probably close to where I drew their boundary line for their map. Don't know if they'll get up here though. So we kind of told them to stay down low and concentrate on where they know the soils are. I mean, up here it's bedrock. It's pretty, but it's bedrock. Okay, here's the edge. Maybe you can hear that there's the highway right down there. Right across the highway is Battle Creek. So if you're familiar with the area, if you continued on Battle Creek down this valley, probably 2 miles or so, and then the road goes up above, of course the creek stays down below, you get to the area known as Hippie Hole, or we used to call it Big Falls as well. Real popular location for swimming. Nice ponds on a waterfall on Battle Creek. So we're about 5-6 miles, I guess it would be south of Rockerville in Horsley Gulch. So it's a really nice area. If you're local, this is a great place to come for a Saturday afternoon or a Sunday afternoon hike through the woods. You can just strike out up here and just go. Okay, so I'm not going to go too much further along this ridge before I drop down. And this is all for the views right now. Moss. So wet, damp up here. Moss everywhere on the rocks. So typically, you know, Black Hills is a pretty wet environment. There's a lot of shallow groundwater just about everywhere, and a lot of little seeps and springs in the valleys, and vegetation, and you'll see moss all over the hillsides. It's kind of indicative of the springs. Well, howdy everybody. This is Wednesday of week 3. I didn't do any filming yesterday because it was rainy all day. And so today is kind of a field trip day. We call it mensuration, which is measurements. And we are out at several locations today. We have like 9 or 10 stops we are making, and most of them are dealing with either surface water and or groundwater. And they're doing a series of calculations, determining discharges and flows, and using different types of tools, estimations, and various techniques to determine surface water flow and look at groundwater and those types of things. So right now we are down at Doty Spring. If you saw an earlier video from last summer, one of the first videos I did, came down here with Morgan and Briggs, and there was a family here at that time. We couldn't stand at the water, but there's the spring right there. So water flowing right out of the Madison. And this is extremely karstic in here, and karstic just means that it's got cave features in it, dissolution passages. So all these huge dissolution passages everywhere you look in this piece of limestone. It is karstified very heavily. And so we're down here doing a paleo hydrology calculation. This was an area in 1972 during the flood where the discharge here was huge. The discharge of the creek right now is probably in that 30 cubic feet per second range. This site almost 50 years ago, today is May 31. The flood was June 9, 1972, and the discharge where I'm standing right here was somewhere in the neighborhood of 40,000 cubic feet per second. Right now, again, it's about 30 cubic feet per second, so quite a bit higher. The flood, I would have been standing right here in probably 20 to maybe even 30 feet of water moving at, I don't know, 15 or 18 feet per second. And so we'll be calculating that as part of their calculation. They'll be calculating a velocity and then trying to fit the flood through a profile through here based on the evidence that we see for where the water level was at that time. And I think we looked at some of those things in that video last summer, but they're going to end up with a calculation that's probably pretty close to what the actual conditions were here. A lot of debris was probably in this flow coming down through this narrow canyon, and so blocked the flow. A lot of resistance. Resistance is in the equations we use to determine velocity, and so if we don't use a abnormally high resistance factor, we get values of like 70,000 cubic feet per second, which is about double what was actually here. So we have to raise our roughness value to something that is really kind of abnormal, but in these situations that we're trying to mimic and to model, that's what is required. So they are just having a bit of lunch right now. We had to cross the creek twice to get here. Only one fell in, so that's good. She's wet, but doing good. So I'm just coming up onto the first terrace surface here, and then I'll walk back and try to find some flood evidence. There's a couple of terrace levels in here. I'm on one. You can see out here it's relatively flat. A lot of trees, so the trees count for roughness. And again, we looked at this at the video I did last summer, and then here's another terrace bumping up. You can see all the rock and gravel, the boulders, and it goes up about head height, so roughly 6 feet up here in height, and you get to another terrace level, and it goes back another 50 yards, and then it actually bumps up again about another 6 or 8 feet to a third level terrace. So this is quite an extensive fluvial system that has been developed in this area through time. We're trying to find a tree that has flood marks on it. This one does. So there's a mark from 72, but that's low. You know, we're looking for things up high that are going to give us water. And they exist. There's 2 or 3 trees here that have pretty high marks on them. And that's what we're going to use for elevation. Those marks are probably flood marks as well. 2 of them there. Looks like one about the same height on the neighboring tree. So those are probably flood debris marks as well. And that's about the height that we're looking for. Okay, here's the one I think that we use as a marker. So you can see this thing is pretty well skinned up, and the bark has been totally chewed off up to an elevation above my head. And so given a topographic map that was actually contoured in here using a alidade and a plane table, the elevation on this has been determined. And so once they find that, then they can go, this is at least a minimum of high water, and they can project this across to the topography and intersect it up there on that side. And then they go the other way and intersect it with the cliff on the other side of the creek. And that's the cross section that the flood water flowed through.